Electron density of F1, F2 layers of ionosphere is 2 into 10 raised to 11, 5 into 10 raised to 11, and 8 into 10 raised to 11 per meter cube respectively. What is the ratio of the critical frequency for the reflection of radio waves? Now, here are the options. Now, we know that the critical frequency Fc is directly proportional to the square root of n, which is the electron density. So, critical frequency of E is to critical frequency of F1 is to critical frequency of F2 will be equal to 2 into 10 raised to 11 raised to half is to 5 into 10 raised to 11 raised to half is to 8 into 10 raised to 11 is to half, which will be equal to 2 is to 3 is to 4. Therefore, the correct answer is option C. In a radio receiver, the short wave and medium wave station are tuned by using the same capacitor but coils of different inductance Ls and Lm respectively. Then A. Ls is more than Lm, Ls is less than Lm, Ls is equal to Lm, and D. None of these. Now V is equal to C upon lambda. Therefore Vm, which is the frequency of the medium wave, will be equal to C upon lambda m, and Vs, which is the frequency of the short wave, will be equal to C upon lambda s. Now, because lambda m is more than lambda s, which implies that frequency of the medium wave is less than frequency of the short wave. Now, also, Vm is equal to 1 upon 2 pi root of Lm into C, and Vs is equal to 1 upon 2 pi to root of Ls into C. Therefore, which implies Vm upon Vs is equal to root of Ls upon Lm, which implies that Ls is less than Lm. Therefore, the answer for this is option B. The impedance of a coaxial cable when its inductance is 0.40 microH and capacitance is 1 into 10 raised to minus 11 farad can be A 2 into 10 raised to 2 ohms, 100 ohms, 3 into 10 raised to 3 ohms, and 3 into 10 raised to minus 2 ohms. Now, the capacitance is given by the formula Z is equal to root of L upon C. Therefore, substituting the value of L and C from the question, we get Z is equal to 0.40 into 10 raised to minus 6 upon 10 raised to minus 11, which is equal to 2 into 10 raised to 2 ohms. Therefore, the correct answer is option A. An amplitude modulated wave is modulated to 50%. What is the saving in power if carrier as well as one of the side bands are suppressed? Here are the options. Now, the power in the sideband is given by the formula PSB is equal to PC into MA upon 2 the whole square, which is equal to PC into 0.5 the whole square upon 4, which is equal to 0.0625 PC. Now also the total power P will be equal to PC 1 plus MA the whole square upon 2, which is equal to 1.125 PC. Therefore, the percentage saving will be equal to 1.125 PC minus 0.0625 PC upon 1.125 PC into 100, which is equal to 94.4%. Therefore, the correct answer is option C. A ground receiver station is receiving a signal at 5 MHz and transmitted from a ground transmitter at a height of 300 meters is located at a distance of 100 km from the receiver station. The signal is coming via a space wave, sky wave propagation, satellite transponder, all of these. Now, first, we have the maximum distance covered by the space wave communication is D is equal to given by 2RH 2 into 6.4 into 10 raised to 6 into 300, which is equal to 62 kilometers. Now, the critical frequency Fc is given by 9 into Nmax, which is the electron density, which is equal to 9 megahertz. Now, since 5 megahertz, which is the receiving a signal 5 megahertz, the receiving signal is less than the critical frequency, it is a skywave propagation. Therefore, the correct answer is option B. The bit rate for a signal which has a sampling rate of 8 kHz and where 16 quantization level have been used is, here are the options. Now, if n is equal to the number of bits per sample, then the number of quantization levels will be equal to 2 raised to n. Now, 16 quantization levels have been given. Therefore, 2 raised to n will be equal to 16. Therefore, n will be equal to 4. Therefore, the bit rate is equal to sampling rate into the number of bits per sample, which is equal to 8000 into 4, which is equal to 32,000 bits per second. Therefore, the correct answer is option A. 500 Hz modulating voltage fed into an FM generator produces a frequency deviation of 2.25 kHz. If the amplitude of the voltage is kept constant but frequency is raised to 6 kHz, then the new deviation will be, here are the options. Now, MF will be equal to the deviation upon the modulating frequency, which is equal to 2250 upon 500, which is equal to 4.5. Therefore, the new deviation is equal to 2 into MF into FM, which is equal to 2 into 4.5 into 6, which is equal to 54 kilohertz. Therefore, the correct answer is option B. An antenna current of an AM broadcast transmitter modulated by 50% is 11 amperes. The carrier current is, here are the options. Now, the carrier current IC is equal to I root mean square RMS upon root of 1 plus MA square upon 2, which is equal to 11 upon root of 1 plus 0.5 the whole square upon 2, which is equal to 10.35 amperes. Therefore, the answer is option A. A photodetector is made from a semiconductor with Eg is equal to 0.73 electron volts. What is the maximum wavelength which it can detect? Here are the options. Now, the limiting value of Hv mu is Eg such that Hv is equal to Hc upon lambda, which is equal to Eg, or lambda is equal to Hc upon Eg. Now we have to find the value of lambda. Now we know H is the Planck's constant, whose value is 6.63 into 10 raised to minus 3 34 joules, and C is the speed of the light, which is equal to 3 into 10 raised to 8 meter per second, and Eg is given here as 0.73 electron volts, which on converting into joules will give the value as 0.73 into 1.6 into 10 raised to minus 19 joules. Hence, the answer after calculating all this is 1703 nanometers. Therefore, the correct answer is option B. Consider an optical communication system operating at lambda is equal to 800 nanometers. Suppose only 1% of the optical source frequency is the available channel bandwidth for optical communication. How many channels can be accommodated for transmitting audio signals requiring a bandwidth of 8 kHz? Here are the options. Now first we have to find the optical source frequency F, which is equal to C upon lambda. C 3 into 10 raised to 8 upon lambda is 800 nanometers, which is 808 into 10 raised to minus 9, which will give us 3.8 into 10 raised to 14 hertz. Now, only 1% of the optical source frequency is available. So 1% of 3.8 will be 1 upon 100 into 3.8 into 10 raised to 14. which will be equal to 3.8 into 10 raised to 12 hertz. Now, therefore, the number of channels that can be accommodated is equal to total bandwidth, B bandwidth, upon bandwidth needed per channel, which is equal to 3.8 into 10 raised to 12 upon 8 into 10 raised to 3, which is equal to 4.8 into 10 raised to 8. So the correct answer is option A. In a diode AM detector, the output circuit consists of R is equal to 1 kilo ohms and C is equal to 10 picofarad. A carrier signal of 100 kilohertz is to be detected. Is it good? Here are the options. Now, in an AM detector, the condition for demodulation is 1 upon Fc should be less than Rc, maybe way less than Rc. Now, here 1 upon Fc is equal to 1 upon 100 into 10 raised to 3. 100 kilohertz, which is equal to 10 raised to minus 5 seconds, and Rc is equal to 10 raised to 3 into 10 raised to minus 12 seconds, which is equal to 10 raised to minus 8 seconds. Here we can see that 1 upon Fc is not less than Rc as required by the above condition. Hence this is not good. Hence the answer is B. No, it is not good. A sky wave with a frequency 55 MHz is incident on D region of Earth's atmosphere at 45 degrees. The angle of refraction is, here are the options. Now, the electron density for D region is 400 electron per centimeter cube. Now, we know that NEFF is equal to N0 into root of 1 minus 80.5 N upon V square, where N is the electron density and V is the frequency. So, substituting the values, N0 is always 1 minus 80.5 into 400 into 10 raised to 6 upon 55 into 10 raised to 6 the whole square, which is equal to 1. Also, NF is equal to sin I upon sin R, which is equal to sin R is equal to sin I. Since NF is 1, therefore sin I will be equal to sin R. Therefore, R will be equal to I will be equal to 45 degrees. Therefore, the correct answer is option B. 1000 kHz carrier wave is amplitude modulated by the signal frequency 200 to 4000 Hz. The channel width of this case is, here are the options. Now, we know that the bandwidth is equal to twice the frequency of modulating signals. So here the modulating signals are in the range between 200 and 4000 Hz. So bandwidth will be equal to 2 into 4000 Hz, which is equal to 8000 Hz, which is equal to 8 kilohertz. Therefore, the correct answer is option A, 8 kilohertz. In amplitude modulation, the bandwidth is twice the audio signal frequency, thrice the audio signal frequency, thrice the carrier wave frequency, twice the carrier wave frequency, sum of the audio signal frequency and carrier wave frequency. Now, we know that in amplitude modulation, bandwidth is equal to frequency of the upper side bands minus frequency of the lower side bands. Now, V upper side band USB is equal to frequency of the carrier wave plus frequency of the modulating wave, and V LSB is equal to frequency of the carrier wave minus frequency of the modulating wave. Therefore, bandwidth will be equal to Vc plus Vm minus Vc minus Vm, which is equal to 2 into Vm, which is the audio signal frequency. Therefore, the correct answer is option A. A carrier frequency of 1 MHz and peak value of 10 volt is amplitude modulated with a signal frequency of 10 kHz with a peak value of 0.5 volts. Then the modulation index and the sideband frequencies respectively are, here are the options. Now, first we need to find out the modulation index, mu, which is equal to AM upon AC. AM is given as 0.5 volts and AC is given as 10 volts, which is upon 10 volts, which will be equal to 0.05. Therefore, mu is 0.05. Now, the sideband frequency VSB is given as VC plus minus VM, which is equal to 1 plus minus 0.010 megahertz. Since the answer is in megahertz, we convert the 10 kilohertz to 0.010 megahertz. Therefore, the correct answer is option A. A diode AM detector with the output circuit consisting of R is equal to 1 kilo ohms and C is equal to 1 microfarad would be most suitable for detecting a carrier signal of, here are the options. Now, we know that for demodulation 1 upon Vc is less than Rc. Therefore, here R is equal to 1 kilo ohm and C is equal to 1 microfarad. Therefore, Rc will be equal to 10 raised to minus 3s. So, out of all these 5 options, 1 upon Vc should be less than Rc. Now, out of all the options, only in option E, 1 upon 10 into 10 raised to 3 will be equal to 0.1 into 10 raised to minus 3, which is less than Rc. Therefore, the correct answer is option E. A 1000 kHz carrier wave is modulated by an audio signal of frequency range 100 to 5000 Hz. Then the width of the channel in kHz is A10, B20, C30, D40 and E50. So now we know that bandwidth is equal to 2 into the frequency of modulation. Now here the frequency of modulation is 5100 to 5000 Hz. So we'll take the higher one, which is equal to 2 into 5000 Hz, which is equal to 10 kilohertz. Therefore, the correct answer is option A. The wavelength of red light from HENE laser is 633 nanometers in air, but 474 nanometers in the aqueous humor inside the eyeball. Then the speed of red light through the aqueous humor is, here are the options. Now, mu is inversely proportional to the speed of the light, which is inversely proportional to lambda. Therefore, the speed of the light will be directly proportional to lambda. Therefore, V1 upon V2 will be equal to lambda 1 upon lambda 2. Substituting values, we get the value of V2 upon V2 is equal to 633 upon 474. Therefore, V2 will be equal to 2.25 into 10 raised to 8 meter per second. Therefore, the answer is option C. The area of the region covered by the TV broadcast by a TV tower of 100-meter height is, there are the options. Now, the radius of the earth is given as 6.4 into 10 raised to 6 meters. Now, we know that TV range D is equal to root of 2RH. Therefore, the area covered by the TV program is equal to pi into D square, which is equal to 2 pi RH, which is equal to 2 into 3.14 into 100 into 6.4 into 10 raised to 6, which is equal to 128 pi into 10 raised to 8, which is therefore area will be equal to 1.28 pi into 10 raised to 3 kilometer square. So the correct answer is option B. The phenomena by which light travels in an optical fibers is A. Reflection, refraction, total internal reflection and transmission. Now, in reflection, when light hits a medium, it is reflected back totally. Now, in diffraction, when light hits a medium, it is refracted or deviated by some angle and it passes through. Now, in total internal reflection, when the light is incident upon a medium of lesser index of refraction, the ray is bent away from the normal, so the exit angle is greater than the incident angle. Yet such reflection is commonly called as total internal reflection. Now, in optical fiber, when the light hits the core, it hits the core at an angle which is greater than the index of lesser than the index of refraction. Therefore, it is refracted by an angle greater than normal. And this continues on happening as long as the light stays inside the optical fiber. Hence, this phenomenon is known as total internal reflection. So, the correct answer is option C. In an FM system, a 7 kHz signal modulates 108 MHz carrier, so that frequency deviation is 50 kHz. The carrier swing is A 7.143, B 8, C 0.71, and D 315. Now, the carrier swing is given by the formula, which is equal to frequency deviation upon modulating frequency, which is equal to 50 upon 7, which is equal to 7.143. Therefore, the correct answer is option A. Monochromatic light of wavelength 667 nanometers is produced by helium neon laser. The power emitted is 9 megawatts. The number of photons arriving per second on the average at a target irradiated by this beam is, here are the options. Now, the number of photons per T is given by P into lambda upon H into C, which is equal to 9 into 10 raised to minus 3 into 667 into 10 raised to minus 9 upon 6.6 into 10 raised to minus 34 into 3 into 10 raised to 8, which is equal to 3 into 10 raised to 16. So, the correct answer is option B. An AM wave has 1800 watt of total power content for 100% modulation. The carrier should have power content equal to, here are the options. Now, the PT total power is equal to PC into 1 plus MA the whole square upon 2. Here, MA is equal to 1. Therefore, total power is given as 1800 watts, which is 1800 is equal to PC into 1 plus 1 the whole square upon 2. Therefore, PC is equal to 1200 watts. Therefore, the correct answer is option B. The maximum peak-to-peak voltage of an AM wire is 24 megavolts, and the minimum peak-to-peak voltage is 8 megavolts. The modulation factor is A 10%, B 20%, C 25%, D 50%. Now here, since it is peak to peak voltage, we'll take half of both the values. Therefore, Vmax is equal to 24 by 2, which is equal to 12, and Vmin is equal to 8 by 2, which is equal to 4B. Therefore, now the modulation factor M is equal to Vmax minus Vmin upon Vmax plus Vmin, which is equal to 8 by 16, which is half, which is equal to 50%. Therefore, the correct answer is option D. An oscillator is producing FM waves of frequency 2 kHz with a variation of 10 kHz. What is the modulating index? A 0.20, B 5.0, C 0.67, and D 1.5. Now, the formula for modulation index is given by M is equal to delta upon Vm, where delta is equal to frequency variation and Vm is equal to modulating frequency. Therefore, m is equal to 10 into 10 raised to 3 upon 2 into 10 raised to 3, which is equal to 5. Therefore, the correct answer is option B, 5. Laser beam of pulse power 10 raised to 12 watt is focused on an object of area 10 raised to minus 4 centimeter square. The energy flux in watt per centimeter square at the point of focus is A 10 raised to 20, B 10 raised to 16, C 10 raised to 8, and D 10 raised to 4. Now, the energy flux phi is given as pulse power upon area. The pulse power is given as 10 raised to 12 volts and the area is given as 10 raised to minus 4 centimeter square, which will be equal to 10 raised to 16 watt per centimeter square. Therefore, the correct answer is option B. A step index fiber has a relative refractive index of 0.88%. What is the critical angle at the core cladding interface? Now here, relative refractive index is given. Therefore, mu1 minus mu2 upon mu1 is equal to 0.88 upon 100, which implies mu2 upon mu1 will be equal to 0.9912. Now, therefore, the critical angle theta c will be equal to sine inverse of mu2 upon mu1, which is equal to sine inverse of 0.9912, which is 82 degrees 24 minutes. Now, since none of this 82 degrees is not mentioned here and it is not even close to any of the values, therefore the answer is option D. The velocity factor of a transmission line is x. If dielectric constant of the medium is 2.6, the value of x is A 0.26, B 0.62, C 2.6, and D 6.2. Now, here Vf is given as x. We have to find the value of x. Now, the formula of Vf is equal to 1 upon root k, where k is the dielectric constant. Therefore, x will be equal to 1 upon root k, which is equal to 1 upon root of 2.6, which is equal to 0.62. Therefore, the correct answer is option B. Mean optical power launched into an 8 km fiber is 120 HW and mean output power is 4 HW. Then the overall attenuation is, here are the options. Now log 3 is given as 1.477. Now attenuation is equal to 10 log the mean optical power 120 upon the mean output power, which is 4, which is equal to 10 log 30. Now log 30 is given as 1.477, which is equal to 10 into 1.477, which is equal to 14.77 decibels. Therefore, the correct answer is option A. A carrier is simultaneously modulated by two sine waves with modulation indices of 0.4 and 0.3. The resultant modulation index will be A 1.0, B 0.7, C 0.5, and D 0.35. Now, the resulting modulation index of two of the sine waves with modulation index m1 and m2 is given by m is equal to m1 square plus m2 square, which is equal to 0.16 into 0.09, which is equal to 0.5. Therefore, the correct answer is option C.